Hello, I welcome you all to this another interesting screencast. The problem reads: the 75 kg man pushes on the 150 kg crate with a horizontal force F. If the coefficients of static and kinetic friction between the crate and the surface are mu s equal to 0.3 and mu k equal to zero point 0.2, and the coefficient of static friction between the man's shoes and the surface is mu s equals to 0.8, show that the man is able to move the crate. What is the greatest acceleration the man can give the crate? This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. We have a man here who is pushing a crate, and the mass of the crate is 150 kg. We've been asked to show that the man is whether he's able to push the crate, and later on determine the greatest acceleration the man can give the crate. So what we need to do first is to determine the force. The force that this man is exerting on the crate is F. So he's pushing on the crate and the crate will be pushing on him. So we need to let's separate the man from the box so that we write a free body diagram. For the man, we just consider, so we are assuming the man won't move, okay? He will be in static equilibrium, so that we determine the force, and once we determine the force, we check for slip on the box, and if there is slip, then later on we can compute the greatest acceleration that the man can give the crate. So let's separate the man from the box, and if we do so, we are going to have the following. Okay, so we've separated the man from the box, so we have a force here exerted, okay, by the man, and the box exerting the force on the man. Okay, so this is F, this is also F, so we need to find F from the man. So then this man is going to experience friction opposing this force, so we'll have friction from all the contacting surfaces, this one, and then we are going to have a normal force like so, and then we'll have the weight of the man acting through the center of gravity. Right, so let's call this N, let's call this F, and this F here, it is a static friction. Okay, let's call this W. Right, so let's work on this first and then we'll come to this later on. So what we have here, we'll need N. So we'll say again here we are using static equilibrium for the man. So say summation of forces in the y equal to 0. We are using static equilibrium for the man, and we are assuming he's not going to move. He will just be in this position, but he will just be at the verge of moving. Okay, so what do we have? We have N minus W equal to 0. And therefore our N will just be W, which is equal to mg. Okay, and N is just equal to 75. That's the weight of the man, the mass of the man times 9.81, and our N is equal to, if we computed our N will be 75 by 9.81, which gives us a 735.75 newtons. So this is the value of N. Let's find out Fs. So Fs is just equal to mu s n, and Fs therefore is just going to be equal to 0.8 times 735.75. Therefore Fs is just going to be equal to 735 by 0.8. This gives us a 588.6. Okay, 0.8 by 75 by 9.81, 588.6. That is the maximum force that the man can exert on the box before he begins to sleep. Okay, so having done that, we found the maximum. So now let's check for sleep on the box. So if the box is having this force like this, then we expect the friction force to be in this direction. Then we'll have the normal force like so. Then we'll have the weight of the box. So this is W, which is just equal to mg, and is equal to 150 by 9.81. Okay, and this is F. Okay, and this is N. So we need to check for sleep. So what we do is, let me just create a boundary here. So we need to check for sleep. Let me create a boundary here. Alright, so let's check for sleep if there's going to be any sleep on this particular box based on this force that we found. So we found a force here of 588.6, which is the same one also here. Okay, right, so checking for sleep for the box, for the crate. What we need to do is let's calculate the friction force mu s n. Okay, let's calculate n first for the box. So say summation of forces in the y equal to 0. Again, we don't expect any movement in the y direction. So we are saying this n is just going to be equal to W, which is just equal to 150 by 9.81. Okay, and then mu s times n, which is just going to be equal to 0.3 by 150 by 9.81. This gives us, that's 0.3 by 150 by 9.81. This gives us a 441.45 newtons. Okay, 0.3 by 150 by 9441.45. Okay, so therefore we know that our F, which is equal to 588.6 newtons, is greater than mu s, which is equal to 441.45. Therefore sleep will take place. Okay, so if sleep will take place, then we can compute now Then we can now calculate the kinetic. Since slip will take place between the crate and the surface where it is resting, we will use mu k to compute the acceleration. Okay, all right. So we use mu k to compute the acceleration. We can draw our kinetic diagram like this. There we go. Ma. So say summation of forces in the x is equal to max, where we know everything already here. We just work them out. So we have, and then this is our coordinate. This is our coordinate like so. This is our reference coordinate. Okay. This is our positive x. This is our positive y. All right. So we know that we have f minus fk, which is going to be equal to max, and our f is just 588.6. So we are calculating the max, the greatest acceleration, minus mu k, which is just 0.2 by 0.2 by n, then by 150 by 9.81. Okay, then equal to 150 by ax, and therefore our ax, okay, is just going to be equal to let's work it out. So 5886.6 minus 0.2 times 150 times 9.81 divided by 150. So this we just get a 1.962, and therefore our ax greatest, okay, our ax greatest is just equal to our ax greatest is just going to be equal to 1.96 meters per second square. Right, I think this is about it. We can outline our solution, and this acceleration is in this direction like this. In this direction like this. All right, so this is the final answer. Yeah, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.